As we were thinking.
You were thinking, yeah. Don't take your stuff out of the room. That's a good way to be thinking. So here it is. Take a look. No, it's not a test. We don't have a test right away. Miranda's got an email from me as well. Check your email. Ashley. Okay, so for number one, I think if you made an error in there, I went and I made some corrections in purple. I believe that I did the same for number two. And I think I did for number three, as well as number four. A lot of you forgot to multiply by 2 at the end with number 4.
Oh, man.
Yeah, so I circled the times A for you. Number 5 is less than, though only one of us saw that.
Really?
Who was that?
Because I don't know, I think a lot of you took the 2 times the 52 maybe and called that 104, but it subtract that much. So that made the whole thing negative. So I believe that I made corrections enough on your paper when I graded it for you to understand your errors. If you do not.
So why is it not on?
Yeah, I can't.
For number 5,
Yeah.
why is it not, why is it,
Yeah, we did less than. Yeah, we did less
well,
than.
sure you did, but then if you put in the wrong inequality, that doesn't help.
No, we did.
Which one is the less than?
Well,
Less than is like the one.
So if we did this,
This is the one that, this is the one that.
that's 59, and that's 27. So that's a big number. What is it, 1,500?
1,593.
Okay. So then on this side here, you have this. An order of operations tells us that we have to do the 2 times the 52. Now the order of operations says we have to subtract, and 29 subtract 104 is a negative 75. Plus 7 is a negative 68.
Yeah, we got it right.
Yeah, that is
Yeah, we did that. Yeah, that's exactly what we did.
Oh, you did? Oh.
I was looking at that, like something that long. Yeah.
Okay, hi-ho, I owe. I owe, then I owe almost all of you. I don't know what I was thinking.
That one person, yeah, that one person I got it wrong.
Okay, yeah, so then only one of us got it wrong, sorry. Okay, I will make such correction, and I'll do that before you leave by, keep your quiz out. I'll come around and I'll take a look at yours so that I'll just put down a list of people that I need to change that with. All right, okay, good. Glad you're right. Better all of that than not. Any other questions that you want to correct me on? 7?
Yeah, 7.
Okay, so 1 over 100 million. Is that right, 100 million?
Yeah.
No, 100 billion.
Yeah, her
Is
billion.
that right?
Yeah.
3, 6, 9,
12.
and then 2 more. That's 1 over 100 billion. Is the same as 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
That's what I did.
So it's 11, so you move the decimal point 11 spaces. So if I multiplied a number like 6 times that, you would take this number here and move its decimal point 11 places to the left. Because you're making it smaller. You're making the number smaller, therefore you have to move the decimal point to the left. If you moved it to the right, then this would be like this. Whoops. 1.
But I thought we were doing, I thought we were taking the top one and making the top one into 1. And then that way you would still move it right. Okay, wait, what?
Well, it says to multiply a number by this. So to multiply a number times this, you would move the decimal point 11 spaces to the left. Okay, any more? So 4 we're still on 2. So you had no homework, correct? Can we give them each a couple of sheets, maybe even 3? And if they have more, it's okay, they can always just store it in their book.
Wait, Mr. Dagan?
Yeah,
Wait, so how do we determine if we got an A, B, or C?
your score divided by 13 times 100. That'll give you a letter score. The number possible divided by the total times 100.
That, bring it
Divided by 13. You're going to take the answer and multiply by 100.
Somebody use a sloppy. You said never take a coach. Where are we supposed to pass these tests, or you just?
No, I'll catch up with you before you leave on that one problem, okay? All right, so could you take a look at page 50 since I cannot project it? Yeah, 50, 50. We're skipping scientific notation. We spent a lot of time with that last year. We'll spend more with it again next year.
Oh.
Ryan, are you ready?
Yes, sir.
Okay. All right, so this lesson is on plotting points and coordinate graphs. I am hoping that this is relatively straightforward in its review to you. We will do this lesson, then the next lesson I'll teach you how to do this type of work using the graphing calculators. How to basically plot points and interpret what you're putting onto the graphing calculators. So what they begin with here as an introduction is they talk about the seasonal snowfall in Philadelphia. And they're using something called a scatter plot. And a scatter plot is when you put points on, you have data points, but you don't connect the points with a line because it might not be appropriate to do so. In some situations, we're not really looking at a relationship from one point to the next. They're simply facts, they're pieces of data. I mean, in this case here, they've got all these years from somewhere in the 1880s all the way up to 2000 and something. And they're saying that each year there was a set amount of snowfall. So, just looking at this in a rough sense, each year gets a point like this. But if we were to connect them, it would be like, we're saying that there's an in-between. So for example, when we do a sequence like this, where the first term is 1 dot, the second term is 3 dots. And then the third term is 6 dots like this. It's called a triangular sequence. If we look at this, this is the first, this is the second, and this is the third. There's a count of 1, a count of 3, and a count of 6. So if we were going to make a table, this is the term number up on top, and that's the count of dots on the bottom. It would not make sense to make a graph and connect those points because there's not an in-between. There's not a 1.5 term. There's the first one, the second one, the third one. There's nothing between. So here, if we're saying that this is 1899 and this is 1900, there's not a year that exists between that. So we just create a scatter plot and do not connect points. So what a scatter plot does is it plots points from data. And the data there in Philadelphia is how much snowfall they received in a year. So out of all of these years, how many different years total did they receive more than 50 inches of snow? How many years total did they receive more than 50 inches? 3. How did you find that?
3 dots above the number.
So if you have this graph here like so, and you found 50, and you drew an imaginary line like that, a horizontal line, there's 3 dots above the line. So 3 years. How many years did they receive no snow? Looks like maybe 2, huh? Although that one out by 2000, it almost looks like the dot is just above, like maybe it's at an inch. Are you guys here? Are you on page 50? Play the game. Certainly back between 1970 and 1980, that's a 0. But sometimes they're a little bit more difficult to look at, so what we have to see is we have to see what the data table is. How much snow fell during the year 2000?
Like a few inches, maybe?
Around 29.
So you're saying around 29 and you're saying a few. So
Year 2000.
are there 2 dots on it?
Yeah,
I only
there's
see
one
one.
dot on that's a
I
little
only
over
see-
the 2000 line,
Yeah.
and then
Yeah.
there's another one that's.
So there's one right on it, one right over.
Yeah.
Yeah. So it says beginning October of the preceding year. So maybe the dot just beyond the 2000, the one that's around 19, maybe that's the dot that goes with the year 2000. What's that?
There's no one, okay.
19 inches around 2000.
There's probably like 1.2.
What if you go back to 1900? They highlighted a dot. How many inches of snowfall for the year 1900? Maybe 20. So we read these just like a line graph. We go straight up from the input and straight over for the output. Okay. So when we make a graph, the horizontal line is called the what? The horizontal is the x-axis, and the vertical is the y-axis. Okay. In each of these 4 areas, if we show all 4 of the quadrants, each of these is numbered. They're given Roman numerals. This is quadrant 1. This is 2, goes counterclockwise. This is 3, and that one is 4. So when we're in quadrant number 1, are the x values positive or negative? I think they're positive. So if I was to write an ordered pair like this, x comma y, or I keep wanting to write x. the x is positive. What is the y? Positive or negative? This is going to be positive also. How about if we come over here? What is the x in number 2? It's going to be negative. And the y is going to be positive. How about down here, number 3? Negative, negative. Negative x, negative y. How about over number 4? Positive x, negative y. Oh, I wrote x. Look at the x. Thank you. There we go. I can rotate it 45 degrees. So if you put a point anywhere along the x-axis, so if we had a point anywhere along here, what will be the y value? It can be 0, so you're not above and you're not below. Whereas if we put a point anywhere along here, what is the x value going to be? There it's going to be, there it's going to be 0. So if we have a line that crosses the y-axis, it has an x value of 0. We call it the y-intercept, or where it crosses. Here, the x value is 0, because we don't move left and we don't move right. So for example, a point up here may be like 0, comma 3. So the x is going to be 0. X will always be 0 along the y-axis, and the y will be 0 along the x-axis. If I had a point out here, that might be like 4, but 0 up and down, 4, comma 0. So this year we're going to start looking at those types of things and start trying to recognize them. This point here, what is the ordered pair for that point? Where the x and the y-axes meet. So 0, 0. So 0, comma 0, that's referred to as the origin, where everything begins. If we write an ordered pair, know that this is the x-coordinate. Of course, that's the y-coordinate. But these are all things we've seen in the past. So, your homework is going to be on page 53. So, page 53, I'll write them up here. So when you set yourself up on graph paper and you draw in your axes, make sure that you use a straight edge and draw each of the axes right on the lines as accurately as you can. You do not need to label each and every point that you put onto your graph. I remember from last year, sometimes we would do that. We would end up labeling each individual point. It's not necessary, as long as you have a scale mark. So make sure you label your axes, put a scale on your axes, and give any graph that you make a title. And I think you have enough graph for that to work. If you ever need more, let me know. If you have extra graph paper, just fold it, keep it in the book. Sure, go ahead.